Hey guys, I'm rocking the call center look today with my headset as we go through the first part of Chapter 7. 7.1 and 7.2 are actually very small sections of this particular chapter and flow really, really well together. So we're going to go ahead and do both of them together. We're going to start by talking about momentum, which is a property of a moving object that is defined as mass times velocity. All right, it is the moving inertia of an object. How hard is it to get it to move or stop? So we are looking at the fact that it is that mass times velocity quantity here. The equation for momentum is pretty simple. We are looking at the fact that momentum is a lowercase p. We did see uppercase p in the last chapter with power, but now we're dealing with a lowercase p is equal to mass times velocity. Notice there are arrows above the p and the v here. Hopefully you remember that that means that these quantities are vectors. Right, which means they have not only a magnitude or size, but also a direction. We will talk about the fact that momentum is in the same direction as the velocity, where we get that from. Just like we've talked about before, when we find the total of something, we add them all together. So the total momentum will be the sum of all of the momentums, just like the total force or net force is the sum of all the forces. The total work is the sum of all the works. Right? This concept is not going to change. Right? We already talked about the fact that momentum is mass times velocity. What we haven't talked about yet is the units. We can see the fact that mass here is going to be kilograms, and then velocity is going to be meters per second. We do not boil this down into a new unit, into a specific unit. It is literally what you put into it. We put in kilograms and meters per second, we get out kilograms and meters per second. When we are working on mastering physics, and that's how we're doing things from now on at this particular point in time, you are going to need to type the kg, and then when you hit Shift 8, it's going to give you the little multiplication symbol, and then meter/second. And this will go ahead and auto sort of format for you the way it needs to in the units box for quizzes and that kind of stuff. So we are going to look at the fact that an object's momentum changes anytime an object's mass and velocity change. This is going to matter when we move forward into other sections in this particular chapter. All right, so let's go ahead and start with an example problem. So using the same problem-solving techniques we talked about previously, we read the problem. All right, a 1,200 kilogram car is driven through town with a speed of 15 meters per second. What is the magnitude of the car's momentum? All right, so we read the question. Now we get to do the next easiest part, identify our known and unknown variables. So we can see the fact that we have this quantity here. This is our mass. Right? The next thing we're given is a speed. And we want what is the momentum. I'm going to go ahead and put this little momentum in these absolute value bars just to start getting you used to that notation that you're going to see on Mastering Physics that talks about the fact that if you're looking for the magnitude, the direction doesn't matter. We're going to drop those negatives and positives in this particular case. So the magnitude of the momentum. We just learned previously that momentum is equal to mass times velocity. Well, we have all that information. It's solved for the variable that we want. We can go ahead and do the easy part of physics, the plug and chug. All right, and when we do that, I get 18000, so 18,000. And like I said before, what you put in is what you get out. We put in kilograms and meters per second, so that's what we're going to get out of this. We're going to get kilograms, meters per second. All right, and we did not need to make any additional adjustments for sig figs. We had 2 sig figs here, we had 2 sig figs here, and we only got 2 sig figs here. So we are good on sig figs. One thing on sig figs I do want to note is when you are working on mastering physics, the default the system takes is actually 3 sig figs, unless otherwise stated. So some of you guys have been ending up getting some of your questions wrong, and I gave you credit back for them on the homework if you brought the number of sig figs down to 1 the way the question sort of formatted it. I'm having issues with getting the system to force the number of sig figs and the numbers it provides to you while checking for 3 sig figs every single time in the answers. So just be aware of that. I am trying to fix it. But when in doubt, 3 sig figs should be safe and solid. All right. So I already mentioned the fact that when looking at this definition of momentum, this momentum is going to point in the same direction of the velocity. This is a similar relationship that we saw previously with this equation. This force pointed in the same direction as the acceleration. All right? And remember, the little arrows on top just say that it is a vector quantity and contains a direction. The little arrow does not actually tell you what the direction itself is. So keep that in mind. Right? So the vector nature does matter. That means if we have things to the right and we add things to the left, we are going to have things that are going to cancel out. All right, just like we did with forces and that kind of stuff before, we do need to take that directional thing into account when we are doing our adding for our total momentum. All right, we've already established the fact that total momentum is the sum of all the momentums, and that unit for total is going to be the same as the individual momentums. Pretty standard. All right, we're going to go ahead and work on an example problem here dealing with the idea of total momentum and that vector nature of these particular questions. As soon as I start drawing, our picture is going to stop animating, so just be aware of that. So we do see the fact that we have a person throw some bread into a duck pond, 2 4-kilogram ducks and 1 7.6 kilogram goose paddle rapidly toward the bread from opposite directions. All right, so if I have my pond, if I have my ducks here and my goose here, they're going to come in like this, and he's going to come in from like this to get the bread. Okay. So we are seeing the duck swim at 1.1 meters per second, and the goose swims with a speed of 1.3 meters per second. We want to find the magnitude and the direction of the momentum of the 3 birds. All right. Based on this particular graphic, I've gone ahead and drawn here where I have my 2 ducks and my goose going towards the bread. If we go ahead and establish the fact that to the right is generally positive, right? That means my ducks are going to be positive and my goose is going to be negative. So our total momentum, like I said before, is going to be the sum of the individual momentum. So that's the momentum of the first duck plus the momentum of the second duck plus the momentum of the goose. Right? We also know that momentum, as we established previously, was mass times velocity. So we can go ahead and continue to expand this equation out. So my P total is equal to the mass of the duck times the velocity of the duck plus the mass of the duck times the velocity of the duck plus the mass of the goose times the velocity of the goose. All right. Because the 2 ducks are identical, we can actually combine those 2 terms. All right, so I have 2 times the momentum of the duck. All right. We have everything else that's going to be in our problem. We have the masses of our ducks. We have the mass of our goose. We have the velocity of our duck and the velocity of our goose. We're going to go ahead and plug that information into the equation. Let me go ahead and organize my information a little better. So I'm following those problem-solving procedures. Notice I did go ahead and put a negative sign inside the in front of the velocity of the goose. Remember, that's because that goose is moving in the opposite direction from the ducks. So we are going to keep that negative sign when we put everything into our equation here. All right, and when we plug that into our calculator, 2 times the 4 kilograms times the 1.1 meters per second plus the 7.6 times the negative 1.3, we do get a total momentum of negative 1.08 kilograms meters per second. That means the total momentum is in the same direction of the goose. All right. So we could rewrite this as we want it, if we wanted to 1.08 kilograms meters per second in the direction of the goose. All right. So that's also a perfectly valid way of explaining that. So just be aware of that particular option. All right. So it goes ahead and takes us through total momentum.